Here are a few you try it's with new reactions. So go ahead and do 1-phenyl 2-propanone with dimethylamine and catalytic acid. Here's 1-phenyl 2-propanone, and here is dimethylamine. What is the product? And enamine. Notice this is a secondary amine, and so we form the enamine with this compound. Notice the ene is more substituted. I didn't choose to put it here. You want to have the more substituted amine, ene. What is the product of cyclohexanol with cyclohexylamine? That will be an imine. This is a primary amine. Notice there's only one R group on there, a primary amine. So what do we form is an imine. What is the product of acetone with the sodium salt of phenylacetylene? Notice this is going to do a reaction just like the Grignard, followed by an acid wash to protonate. The product is that this is the nucleophilic end, attaches to the carbonyl, and we end up making this into an alcohol. So there's our alcohol group, and here is the acetylide part of the molecule. This carbon is right here. This carbon is right here. And there's the phenyl group right there. What is a product of benzaldehyde with a triphenylphosphenylide formed from 1-chlorobutane? Well, this is the product. Notice you chop this off, chop that off, and stick them together as an alkene. What is the product of dehydration of ethylene glycol and 5-oxohexanoic acid under acidic conditions, followed by reduction with lithium aluminum hydride and then an acid wash? Here's ethylene glycol right here, and here is the 5-oxohexanoic acid. So what's going to happen if we treat this with ethylene glycol? Well, we protect the ketone group. See, now it's protected as a ketal. Now I'm going to treat this with lithium aluminum hydride. Notice, by the way, it said dehydration, so that meant we're shoving this to completion by removing water in the equilibrium. Now we're going to treat this with a lithium aluminum hydride. What does that do? That reduces this acid group. When we wash with acid, not only do we protonate the alcohol here, but we also cleave off the protecting group and give us our ketone back. So how can you make this enamine? Well, this enamine comes from this ketone. See, this, the ketone ends up, this gets cut off, and that was a ketone here. And what amine was it? It was this amine with a hydrogen on there. So these are the two things that make up this enamine. How can you make 1-hydroxycyclohexane carboxylic acid from cyclohexanone? Well, if you look at this, you can see this is an alpha hydroxy acid. That alpha hydroxy acid should make you think of the cyanohydrin. How do we form the cyanohydrin? By treating cyclohexanone with hydrogen cyanide. Now, how do I go from the cyanohydrin to the alpha hydroxy acid? Well, I just cleave it. I hydrolyze the nitrile with acid, and it gives us this. How can you make this alkene from this alkene? Well, there's a couple of ways that you can do this. There are two pathways that I see. One is you can start with the alcohol, or you get the alcohol and dehydrate it to make this more substituted alkene, or you can come from this ketone and use the ylide. In order to get this alcohol up here, what could I do? Well, I could get this from this aldehyde, and that aldehyde could come from this ene. How do I go from the ene to the aldehyde? Oops, this ene can give this ketone too. How do I go from the ene to the aldehyde? By using hydroboration. How do I go from the aldehyde to the alcohol? Well, notice there's an extra carbon here. This is an aldehyde. This is a secondary alcohol. I have to use methyl magnesium bromide to get this there. How can I take this to this? Phosphorus oxychloride is a good dehydrating agent. Now, if I decided I wanted to go the ylide route, I can use an ylide to go from here to here. How do I get this ketone? Well, I can take the ene and I can do oxidative cleavage, and that'll give me this ketone.